Hello, and thank you for checking out my video. Today we're looking at evaluating functions and using function notation. So first I want to talk about what function notation is in a real simple way. Basically, to sum it up, it basically replaces y, but gives a lot of options for notating what a function is and what we're doing to that function. Okay, so let's take a look at an example. So here you see the old way in just regular standard form is to have a regular function where you have an x and a y. And you'll have your y is equal to 2x, and they want to know what is at x, what is the function, what would y be if you plug in 5 for x. So you'll plug in 5 for x, and then 2 times 5 is 10, and that means y is equal to 10. Now, with function notation, we get rid of all this at stuff and just say f of 5, and that's how you say it. You'll say f of x or f of 5, and that means we want to know what this function is when we plug in 5. So what function notation allows us to do is we can say this particular evaluation of the function is at f of 5, but let's say we did a different one at a different number. We will replace this number with that number and say this is the evaluation of the function at that particular number. But as you can see, it's the same. You have f of 5, and we plug in 5, and we do 2 times 5 and get 10. So like I said, it's a replacement for y. And it's still the output. You're inputting 5, and you're outputting 10. So let's take a look at an example. Alright, so here we've got the exact same equation on both ends here. Okay, and we've got, let's do this side over here first. Okay, so I've got y is equal to 2, and I'm going to plug in my x plus 1. So my x is going to be 3. So then I solve it from there. 2 times 3 is 6. Plus 1, and 6 plus 1 is 7. So we know y is equal to 7. But that just says y is equal to 7. So let me show you another example with function notation. So now I could say f of x, but instead of saying f of x, I'm plugging in this 3. So it's f of 3. And that's your y, but it's actually the function when you plug in 3 for x. So you got f of 3 is equal to 2 times what I'm going to plug in here, my 3. And then I solve it the same way. 2 times 3 is 6, plus 1 is 7. So the difference is this just says y is equal to 7. This says not y, but f of 3. This is what the function is when we plug in 3. It gives us some more information when we just look at it. It simplifies things. So another thing, and since we're just dealing with one function at a time right now, because we call it f of x, we can use different letters to name different functions. So let me show you another example, but we're just going to use one function. So let's take a look at this one. So here, and here you got two functions here. One has g of x and one is h of x. They're just two different functions, but it's the same thing as f of x, so don't let that confuse you. So we're going to do one at a time. These are two separate problems, but let's just look at this one here. This function here, h of x. So like I said, it's a replacement for y. So we're going to plug in this -2 in for x. So I've got h of x is equal to negative, I'm going to plug in my -2 minus 1. So I plug in the -2 here. So then I just solve it. This negative times a negative is going to be a positive. So I got positive 2 minus 1. Different signs, find the difference. 2 minus 1 is 1. So h of x, when you plug in -2, and this is what I want to write right here, h of negative 2. So h of x, when you have h of negative 2 here, is 1. Okay, go ahead and pause the video and see if you can solve this one on your own. Alright, so let's take a look at this one. So this one we're going to do g of x, but it's going to be g of 3. So I'm going to write g of 3 is equal to negative, and I'll plug in my x, minus 2. So my x is just regular 3 now. So now I just keep working. Negative times a positive is a negative. Minus 2. Same sign, find the sum. Negative 5. So g of 3 will be negative 5. Again, this is function notation. Function notation. Evaluating a function. Let's take a look at a more complicated problem. But everything stays the same. So we're going to zoom here, and both of these just happen to be f of x, but they could be, you could use different letters. All right. So we're going to go ahead and plug in f of negative 5. So we're going to do f of negative 5. And what would that equal? That'll equal 4 times the negative 5 I'm going to plug in squared plus another negative 5, because you have two x's, minus 5. So I got these two x's here, and I'm going to plug in this negative 5 in here. And once you do that, it's really not even algebra. You're just working order of operation here. So, you're going to start by doing the exponent, negative 5 squared. So that's going to get us negative 5 times negative 5, which is positive 25. So 4 times 25. Plus, well, we got that positive times a negative. I meant to change that to black. But positive times a negative is negative. So we got negative 5 minus 5. Working from left to right here, we're going to do multiplication here. So 4 times 25 will be 100. Minus 5 minus 5. And then 100 minus 5 is 95. And then 95 minus 5 is 90. So f of negative 5 is 90. Okay, go ahead and pause the video here and see if you can get this one correct. Alright, let's take a look at this one. So we'll go ahead and we're going to plug in f of 3. F of negative 3 is equal to negative times the x, the negative 3 I'm going to plug in, squared minus 12. So I'll plug in my negative 3 here. The same x. Alright, so I'll keep working. Now, before you do the multiplication here, you're going to have to do the exponent. So negative 3 squared is negative 3 times negative 3 is positive 9. Alright, minus 12. Now negative times this positive 9 is negative 9 minus 12. Same sign, find the sum. You get negative 21. Alright, so that's it in a nutshell. This is evaluating functions using function notation. Thank you, and